Welcome to Data Center Dialogues, the podcast where we explore the innovations shaping the future of digital infrastructure. Powered by Schneider Electric, we bring you insights from the leaders driving transformation. Today's episode, our very first, includes an update to one of our white papers, How 6 AI Attributes Are Rewriting the Rules of Data Center Design. Joining me is Victor Avelar, Senior Research Analyst at Schneider Electric. Victor, great to have you.
Thanks, Alison. Yeah, AI, always an exciting topic to discuss. And in this paper, it really forces us to rethink everything from the rack density to energy procurement. And we've been having a lot of fun digging into this topic. As you know, it's like every day it seems like there's something new.
All right, well, let's get into it. So let's start with the big picture. Why is AI such a disruptive force to data center design compared to traditional workloads?
Well, one reason is rack densities. I'm sure many of you listening have heard of 100 kilowatt plus racks. Traditional enterprise racks might have drawn 10, 15 kilowatts, something like that. I think Uptime Institute survey has the average density even lower than that. But with AI training clusters, we're seeing 80, 100, even 132 kilowatt per rack with the latest GPUs. So that level of density changes cooling, power distribution, and even grid level planning. Racks need to be bulkier to support that weight. And hyperscalers are redesigning their campuses because their AI cluster is drawing so much more power than they anticipated. So there's lots of challenges that fortunately you can address them, but it just takes a little bit of discussions with your ecosystem of partners.
That's really a transformative shift, right? It's not just scaling anymore. It's a complete different paradigm.
Exactly, and it's accelerating.
Your latest research identifies 6 attributes shaping AI-ready designs. Can you walk us through those?
Sure, and the funny thing is, it used to be 4, like a year and a half ago, and like I said, things are changing so fast. We now have 6, so who knows? Maybe next year we'll have 8, or maybe we'll have 3. I don't know. But here are the 6. The 6 that we have right now is one, the type of AI workload. And this is either going to be a training workload or an inference workload. Training, most people understand. Inference is a word that you may not have heard of, but it's basically when you train a model, you need to put it to work. You need to put it into production. That's called inference. And then you have the second AI attribute and trend, which is communication latency between the GPUs. Some people don't understand that these GPUs all have to communicate together, like in a mesh network. And when that driver is trying to get all these GPUs to work at their optimal, they can't do it when they're waiting for the slowest network connection to finish transferring that data. So if one GPU is still crunching away, all the other GPUs are just hanging out, waiting, doing nothing. And so the network communication is the bottleneck. And how do you remove that bottleneck? By putting the GPUs as close together as possible. This is like perhaps the most important attribute and trend because it's driving the need to put more and more GPUs in the same rack. Right now, you should start going right to rack densities. This is one of the biggest driver driving us to increase rack densities because we're trying to put all these GPUs in one rack for communication purposes, reduce that latency. Okay, so the third attribute and trend is thermal design power, or TDP. This is basically how much power a chip consumes on average. And then we have peak power and synchronous computation. That's 4 and 5, attributes 4 and 5. I put them together because they kind of work together to create a challenge. Peak power means that you're actually going above the TDP. I just told you the TDP was the maximum average. Well, yes, on average, that is the maximum the chip draws. But the peak power goes even higher than that, like 50, 60% higher than that. And so, and it doesn't do it for very long. It just does it in these very short bursts. So when you have those peaks and you combine them with the fifth attribute and trend, synchronous computation, you get this effect on the power supply of your data center. And that is, it's expecting, let's, for example, say it's a 1 megawatt, right? It's a 1 megawatt average draw, but with the peak and synchronization, you're now drawing, let's say, 1.4, 1.5 megawatts. So your data center is going to feel that. You'll perhaps trip some breakers. It gets really hairy if you don't anticipate this kind of load. So definitely traditional data centers will have an issue with peak power and synchronous computation. And then that brings us to the last attribute and trend, which is AI cluster size. This basically means the larger the cluster size, the more of these issues are going to compound, especially the peak power and synchronous computation. If you have such a large, let's say 70% or more of your load is AI training or inference, you may very well overload circuit breakers. You may very well have a problem cooling some of these racks. And if you're large enough, like these hyperscalers and massive colocations, they actually are so large that they're creating issues for the grid. When one of these data centers goes offline, for example, and then comes back online, it literally causes some instability in the grid. So these are the 6 attributes and trends. I know that was a bit long, but the white paper does a very good job detailing each of these and explaining them.
So this isn't about incremental upgrades, right? It's about designing for flexibility and scale.
That's right. And we've been, I guess this year, we've really started honing in on how to anticipate some of these design challenges, starting with the rack density. So in that density, so part of the TDP getting very high, and the idea of putting all these GPUs in a rack, the only way that you're going to do that is to get rid of the air-cooled servers. Why? Because the air-cooled servers have these heat sinks that are very tall. So by definition, your server will be tall. It'll be a 10U server as opposed to a 1 or a 2U server if you put what we call cold plates on top of the chips to cool them. And so when you run water through those, and it's not really water, it's a glycol mix. People call it coolant, but essentially it's easier to say you're running water through the cold plates, and that does a much more effective job at removing that heat. And so it seems simple, but for a traditional data center that doesn't have this equipment in place, it does present some challenges. And depending on what you have, if you have one rack of liquid cooling, you can take care of it without having to install a chiller plant, for example. So there are ways of addressing these things. And goes back to my point about working with your ecosystem of partners, because there are solutions, there are ways to address this. But if you try going alone, you're liable to make a lot of the mistakes that the ecosystem of partners already made. And so you really need to leverage that know-how.
The cooling know-how almost is is important. So because cooling has really always been a challenge, right? But AI seems to have completely changed the game, right? The rules of the game. So what does that mean when we look at the design strategies?
Yeah, and I think you're right. I think the cooling is really one of the biggest challenges, because although we haven't really had to deal with 100 kilowatt racks in traditional data centers, we have in high performance computing. It's not like we have never seen liquid cooling. The high performance computing, the supercomputers, they have had to do that, but that was a niche. Now this is more of, it's coming into mainstream. There's so much that customers are struggling when, one, as you mentioned, the idea of preparing for today, it's 50 kilowatt rack. Next year might be a 100 kilowatt rack. And so we do have this, it's becoming more obvious in the industry today. And so modularity and prefab modules have come into play as a way of hedging what's going to happen next year. So you prepare in a modular way, and that's helping us prepare for the future. Now, the cooling, it's really nerve-wracking, because customers, they've been putting air through their servers to cool them, and now they're buying servers with pipes on them. You're literally putting coolant through an electronic device. And so that's obviously very nerve-wracking, and you get anxious, because now in the paper we talk about this idea of the close coupling of the pipes with the servers with the chiller plant. It's all physically connected, whereas before it was just air, kind of floating around the data center, right? So now we have this coupling, and it starts asking the question, well, who's responsible? Is it the server vendor that's responsible for any failures? Is it the cooling provider? Is it the engineering firm that designed the whole thing? So again, I hate to keep harping on the ecosystem, but you really have to be in sync with all of these partners to make sure your water temperature range is set correctly, to make sure that your filtration and your treatment of that coolant is exactly as the server vendor asked for. So right now, people are actually putting only one server model on one particular loop, and that loop is for X server model. Eventually, and I'm very confident in this, eventually we're all going to become so accustomed to it, it's going to be second nature, and we won't have these issues anymore. I'm really confident in that. It's just that we really are early in this whole game of AI. This is really early days, and there's just a lot of exponential learning that we have to do.
But airflow is not going completely away.
Yeah, you're right. Thanks for bringing that up, by the way, Alison. I actually was checked by a customer on this very point, and I kept calling it liquid cooling, and they're like, the server isn't 100% liquid cooled. So I like to call it hybrid, and I said, you're absolutely right. We should call it hybrid. Sometimes hybrid is a little less clear. Like, what do you mean hybrid? Well, what we should say is it's liquid cooling with 10 to 20% of air cooling. That makes it very explicit. It means that the components like GPUs, sometimes the CPUs as well, are cooled with a cold plate, and the others are cooled with traditional airflow through the server. That doesn't mean that we will see that continuously. In fact, HPE has a server that is fanless. They introduced it last year. So I believe that we will eventually see most of the AI servers be liquid cooled. Why? Because again, those air sinks take up a lot of room. And if we want to put all of this gear in one small package, that being the rack, we really benefit from cooling everything with liquid.
So we talked a lot about cooling. Let's move into energy, right? AI workloads, they are known to be quite energy intensive. How do operators balance performance with sustainability?
Yeah, that's a great question. Yeah, we were just talking about that today, this idea that sustainability is still important, but it's competing against this massive amount of energy use that is AI. And let's face it, when the globe is consuming gigawatts of power, it's very hard to reconcile that with, like, we can't create nuclear plants and hydro plants fast enough, right? So the power has to come from somewhere. So we are battling this thing. For most customers, the answer has been go procure low carbon electricity. Even smaller data centers can improve their sustainability with this approach. But when it comes to these massive hyperscale capacities, energy procurement might mean literally co-locating the data center along a hydro plant or a nuclear plant. We saw some headlines about that this year. There's also, at the same time, there's also many of these larger players getting in line for one of the first modular nuclear plants. So that's another possibility, but that, of course, that's further out. I would say another 5 years before we start seeing those things stood up. So we're helping customers model the demand and response strategies that you can use with some AI-driven software to optimize their energy efficiency. For example, EcoStruxure, it provides real-time visibility, predictive analytics. So you manage these massive loads with those sustainability targets in mind.
So what I'm hearing is software becomes critical, right? So as critical as hardware.
Absolutely. In fact, we have this AI presentation that we update it consistently as we learn more and more. And one of the things we've always said is the software becomes more critical. It's not that the software is challenged by AI, but AI, again, with the densities and the criticality, especially if you're in an inference mode where you're making money on this chatbot or this AI workload, it becomes so critical that you can't afford to not keep, monitor cooling, monitor the temperatures, monitor power to make sure that you're not about to trip a breaker. And there's very little wiggle room here because of the densities that we're talking about. You don't have that much of a leeway as you did with traditional loads. So that's why we always make it a point to say, don't forget about the software, management software, design software, even designing stage, the software is critical. We're also in the early stages and talking about a digital twin. It's basically a digital version of your data center. So you can test things in a virtual environment before you roll it out in practice to make sure that things are working well. So that's another key piece of software to watch out for.
So when you're talking about software and digital twins and virtualization, are we talking also about the Omniverse?
Yes, NVIDIA's Omniverse is probably the best known example of this. Jensen's been in his keynotes talking about this, and not just in data centers, but in factories, creating a digital twin of factories. And it's super exciting to have someone like that in the industry raising awareness to digital twins, because if you've heard of it, most people think it's just a buzzword. This is much more than a buzzword. And as we mature as an industry, as a data center industry, and start using it, for example, grid players are going to love digital twins of data centers because they'll get to test the impact on their grid in a digital way, and right, and make sure that things are going to work. And if it doesn't work, I'd rather know about it in a digital world than in the real world, where millions of utility customers could be impacted negatively, right? So it's a really just another facet of this AI story that's playing out, and it's super exciting.
And one thing that software is really helping right now is with regulations, right, and reporting on metrics that are being required from data center operators, right?
Absolutely. Yeah, and I suspect we're going to be seeing even more legislation coming out all over the world. You can tell it's not easy, so we're just trying to learn from people's mistakes, unfortunately, when it comes to regulation. But I'm confident that things are going to work out in the long run. Like I said, we're in the early stages.
And if you're a CIO or a data center executive listening today, what's your advice for future proofing infrastructure for AI?
Well, so the most obvious one for me is to plan beyond 100 kilowatts a rack. You might start with 20 or 40 or 50, but inevitably, as you adopt the later generations of GPUs, you will start seeing those densities creep up above 100 kilowatts. And while you have some breathing room, that's when you should start planning for it. Don't plan for it when you need the server yesterday. So you got to build flexibility into the power and cooling systems. Like I mentioned before, prefabricated modules is one way. And we heard this from a customer, like they took it upon themselves to use prefabrication as a way of hedging what's to come the year after or the year after that. It's a way to build for what you need today without building an enormous data center all with the same capability. Let's say 120 kilowatts per rack. Well, what do you do when a 200 kilowatt rack comes out? So this is a one way to plan for what your next step is without, betting the bank on one particular requirement or one particular design specification. And this isn't just a vendor conversation. It's you get together with utilities, with the regulators, like you just pointed out, hyperscalers working together in this way. So start with a roadmap that includes energy procurement. You got to make sure you have the power, modularity, software, like we spoke about. And the worst mistake is assuming that AI demand will just plateau and it'll stay stuck at 150 kilowatts a rack. It won't. We've already seen Jensen's roadmap, and whether or not it happens, not sure, but chances are we are going to meet the 1 megawatt rack in that roadmap that Jensen has spoken about. Highly likely that that is going to happen. So we have the roadmap, just a matter of planning for what you need today, and then use modularity as a good way to hedge what's going to come tomorrow.
So the mindset shift is designed for flexibility, right? Not stability. Flexibility is really the key word from what your recommendations.
100%. Yeah, completely agree.
So AI is reshaping everything from rack design to energy strategy. Victor, thanks for sharing these insights. For more details, download Schneider Electric's white paper, How 6 AI Attributes Change Data Center Design. That's a wrap on this episode of Data Center Dialogues, powered by Schneider Electric. I'm Alison Matte. Thanks for tuning in. If this was valuable, subscribe, rate the show, and share it with someone on your team. See you next time as we dig further into the future of energy tech.
The content of this podcast is for informational purposes only, should not be undertaken as financial, economic, legal, business, tax, or investment advice. The information, statements, views, and opinions should not be construed as the provision of advice by Schneider Electric or as an offer to buy or sell any products or services or to make or consider any investment or course of action.